Comparing Two Proportions R tutorial. In the lecture today, you learned how to compare proportions obtained from two independent samples. Jeff derived the form of the confidence interval and then showed how to arrive at the same conclusion using a hypothesis test for the difference in proportions. Let's work through the Rob Ford polls example. Recall that the first poll had 1,050 participants with a support of 57%. And the second poll had 1,046 participants with a support of 42%. Let's enter this information in R under appropriate variable names. We will need to calculate the number of successes for each poll, or the actual number of supporters. So for the first poll, we can multiply n1 times p hat 1 to obtain approximately 598 supporters out of 1,050. And similarly, we obtained 439 supporters for the second poll. Recall that we need to use the round function to obtain a whole number, since we are talking about the number of people. Now we are ready to use the command prop.test. The first argument is the number of successes, combined with the C command. The second argument is the sample sizes, again combined. The third argument is the alternative hypothesis, two-sided in our case, and we will add the optional argument correct equals to false. We'll decipher the output step by step. First, we can see that we obtained sample estimates for the proportions, these being the p-hat values we started with, 0.57 and 0.42. Next, we obtain a 95% confidence interval. This tells us that the true support for Mayor Rob Ford decreased by anywhere between 10.8 and 19.2%. If you wish to change the confidence level, you can do so with the argument conf.level. And above, we see the hypothesis test for the difference between the two proportions. With such a small p-value, we can reject the null hypothesis and conclude the alternative, that the true proportions of supporters differ between the two polls. Do note that for the hypothesis test, the test statistic calculated is not the one we want. Prop.test chooses to calculate a chi-squared test statistic, as opposed to our test statistic, which is derived from the normal distribution. But we can calculate the test statistic ourselves, using the formula that Jeff introduced. First, we'll calculate the pooled p-hat to obtain 0.495, and then we will use it to calculate the test statistic, to obtain approximately 6.87. The p-value for this test statistic will, however, match the p-value obtained with prop.test. So it is safe to use prop.test if you're interested in just a conclusion of the test.